Hey guys, welcome for another video. You are watching.
All right, welcome again, guys. In the last session, we understood what is the current MCP security landscape looks like. So, it's a time to start the security aspects that we're all waiting for. So, before diving into the kind of vulnerabilities that we can uncover, let's try to understand the secure design review, right? As an AppSec, before the MCP server gets developed, right, there is a kind of design review based on the specs or a design specs or a PID document or whatever the naming conventions you guys have for the initial review of how your tool looks like. So there is a standard procedure where AppSec engineer will do the secure design review or threat modeling on that, right? So let's consider as an MCP as a one service that one company has to develop and serve for the consumer. Now, as an AppSec engineer, how one can do a design review, how one can perform the threat modeling, and how one can identify the possible threat points or possible issues that can occur during the design phase itself, and what are the best suggestions that one can give for the developers as a kind of some of the best practices they can implement after reviewing the service document that they have come up with, right? So, yep, let's go ahead and start. I have, created this particular section with a very good, like interactive way where we have some of the generic real world scenarios that we can discuss, not just the theory data. But before going to real world scenarios, we need to understand how we can perform the threat model and what are the components that will be involved in this MCP, right? So, if you observe the actual behavior of the MCP, we can distribute the boundaries into three layers. One is external network, where the end user and the LLM. That is on a client side, where if at all if you integrate your MCP server with a Windsurf or VS Code or a Cloud or whatever it is, there is an external network of your own, and you have your end user, and based on the LLM model you choose, you have your own LLM model, right? And on its own LLM model, there are these possible threats that can happen. We're gonna discuss about that. Like these numbers are something that tells about possible threats, right? Another one is once as you as a user make some prompt for the tool respective tool on your client. Once you give some prompt, that prompt will trigger the MCP client to talk to MCP server. Second layer is AI talking to your MCP server. Based on the tool that you invoke, it will choose the transport layer. If at all, if you have local MCP like server, it will use the HDDIO, or if you have deployed somewhere, then it will use the remote MCP, and the second layer get invokes. And from that MCP server, next is actually calling the backend operations. It can be your APIs or a database, whatever the tool was designed to do, right? These are the main trust boundary or a data flow mechanism that happens in MCP. So far, you guys are already well aware about it with the previous review which we done. So let's give some few minutes to understand the possible threads on the each boundary and each component which we saw. I have a separate catalog I have created for this. So we have almost like 56 threads on an end user component. User can try to have a prompt injection. The only thing you guys should have in idea, we can't control what end user does, right? He can do anything, but we should have a control in our server side, irrespective of what end user does, we have some of the restrictive mechanism, or we have some of the mechanism to identify what's right and what's wrong, right? So the possible threats gonna happen are prompt injection, social engineering, or session hijacking. How this happens if you're using some web-based MCP clients, that can easily happen. And the credential stuffing. I had developed one of the web-based MCP client where you had to use your basic auth to log in. Then you can chat with your web client, something like that, right? And client side tampering. So these are the possible on the user end, but these are not a something very highly focused items, because we can't control. But some of the items like the guardrails on the prompt injections are something we have to be aware about. And some of the items with an LLM, if at all, if we have utilized something like sampling or prompts as a capabilities, we should have some of the jailbreaking capabilities, like we have some of checks around where user trying to jailbreak our LLM, something like that. And the context window manipulations, there are each limit set to the particular chart or context for queries that we make. So there can be some of the bypass on that limits, and data exposure, data extraction via prompts, like than it is designed to do, trying attacker or user trying to fetch the sensitive data, something like that. Hallucination, we're making the LLM to give the wrong information. And token limit, these will be applicable whenever we are utilizing our own prompts or sampling. And MCP client, this is on the transport layer, where the kind of transport that we're going to choose, uh, modifying the JSON or PC, trying to add the different IDs, or modifying the schema. And how possible of message reply attacks, and trying to perform rate limiting by sending like almost like hundreds or 200 connections at a time, and see how the server gonna handle so many connections at a time. We'll discuss each of the in detail whenever we speak about specific section. And on a actual transport layer, MITM and TLS downgrade, if at all, if you guys are using any kind of weak ciphers, certificate spoofing, and protocol smuggling, if at all, if someone is trying to utilize lower version and serving the MCP on a port 80, something like that. And timing, and these colors on each thing, P1 P2 represents whether it's a critical, high, or a medium, or low, something like that, right? Main thing is on a MCP server, validation again against command injection, SQLi injections, path traversal, trying to steal the sensitive files, authorization bypass, and SSRF, right? There is a possibilities of resource exhaustion can happen based on the recursion prompts that we're gonna make for the servers to act upon. Something like if you have a 5 tools or a 10 tools that does a individual task, what if you make your prompt such a way it should call all the tools to invoke. And weak cryptographies, the bunch of other stuff. And backend systems, database compromise, if at all, if you have isolated, if you're not isolated your database, and if you have given direct access to your tools to interact with database, something like that. And API key exposure, sending or logging the error logs, and possible pre-escalation, data poisoning. So there are different scenarios that can happen based on the attack vectors. So let's go back and see the other important items, like how one can perform the threat modeling actually on the MCP server. Let's try to understand as an end user how actually or what happens when I query something to the MCP. As a user, when you make some question to the MCP, it will first reach to LLM. Now LLM will try to understand what is user asking. Then it will ask the client to check for the tools based on the user need. When the tool is identified, then the tool has been called with a specific schema, and that schema has been called and it invoked to MCP server. And MCP server, based on the tool actions, MCP servers calls the backend. If it is an API for some operations, get or post, it will call that. Or if it is a database operations, it will call. Once the call is made, I mean, like, it checks whether it's a valid API or not, and it will check for the authorization, whether you like, are you author, I mean, like, based on the key or OAuth, whatever the configuration you have decided the auth check. It will validate whether this particular API key that user has passed as authorization to make the call. If it is yes, then it will execute the tool request passed from the client to server and server to backend. And based on the execution, the response comes back to the MCP client. MCP client passes to LLM. The LLM will illustrate in a better way for the user in a much more explanation way, right? So how we can map the MCP threat modeling with the stride methodology. When you talk about spoofing, it's all about impersonating the legitimate asset or service, right? So here, spoofing is generally, implicable on the MCP server level, because if you remember in our earlier videos, we mentioned about one CV where uh, our MCP remote was incapable about serving on HTTP, where attacker were able to set up a proxied environment and redirect the client request to the spoofed malicious server, right? So that can lead to the credentials theft or remote code execution, which is already proved on the client side. And tampering, trying to do the right operations on the tools, if at all, if there is enabled, or trying to do a prompt injection, something like that, because there's also tampering on uh, the prompts on the back end. And reputation, the execution logs, right? We should have the proper execution log, something like which tool is executed and what token, like whose token has been utilized to execute this particular tool or action. Information disclosure, something like if at all, if something goes wrong and MCP server throws some error, we should ensure there is no sensitive information has been logged in that. And denial of service, making the LLM on the MCP server to exhaust their tokens, having the recursion MCP, or making huge prompt, or hallucinating the prompt. I mean, like the LLM that is used in a MCP server, right? Even that can lead to DOS, which can make the service unavailability, or we can, like, it can be something like, poisoning the DB as well, right? And elevation of privilege, trying to invoke the tools that you do not have access to, or prompting in such a way to bypass or to jailbreak the prompts to act as an admin, or like anything that you're constrained to do but you're able to do it. That will stand for elevation of privilege. This is how you can map the component versus the thread type and aligning to the stride. And based on a component we have discussed here, you can come up with the impact and mapping to the each component. And based on how where you have implemented this MCP as an environment, you can come up with the attack vector diagram. I'll show you one more important thing that will really help while you guys creating the secure design review for MCP. I had come up with a framework for MCP security. Let me show you. Yeah, I have distributed the whole MCP as a layered structure, like layer one as the infrastructure, layer two as transport, layer three as a protocol, four as capabilities and tools, five as application where it actually runs, and the layer six is a client security. So in the each layer, we have some of the checklist that tells what are the best practices or best security practices you should do as part of design, right? Something like the MCP server should be isolated. As soon as you check this box, there's a one check that is being done. And firewalls rule should be applied on port 8080 and 443. That is something like must. IDS monitoring depends upon the company policy or how they have to, based on the tools they have. And MCP host security, yes, the Docker image should be hardened, and patches. Uh, and similarly, if I talk about transport layer, something like OAuth mechanism should be implemented. Sorry, yeah, and TLS 1.3 something suggested. If you can see, right. And based on the each layer, you can ensure that the uh, proper checkbox is checked based on how you have developed your application, based on the tech spec whatever you have. And based on the checklist you have selected, there is a score given for your MCP server. And there is a status, something like whether your MCP server is still vulnerable. If vulnerable, what is the severity? It's a critical. And if it is I, based on the score, I have a proper scoring systems given here. If you go through it, you'll understand how the scoring system works and on what percentage defines what scoring system. And you can export these particular data to the respective team to identify which controls are implemented, which are not implemented. And you can have a defined structured way to explain the team what will be the impact if we don't implement these mandatory items, right? So I would recommend guys to use this. This is gonna be useful and book kind of thing whenever you're doing the secure design review. And one of the other important thing that one should be have a thought about is how the MCP attack looks like. The major thing is all about prompt injection, trying to steal the sensitive data, bypassing the validation checks, or whatever it is there on in a server, and right, try to steal, right, like that would be the major motto. So some of them looks like direct DB access, how you can access something like exploiting the SQL injection or bypassing input validation, prompt injection attacks, server compromise like by doing RCE or triggering the RCE, social engineering on the samplings or prompts, making them to run on them to run the malicious data. Or if at all, if it is some kind of help desk kind of thing, making them or making help desk agent to foolproof and making it to run the malicious data or remote code execution, something like that, right? We'll discuss about attack trees when we discussing about the some of the real world scenarios. We have some of the data that has been generated for that. Yeah, this is how the risk assessment looks like. Something like the highest possible attack vectors, or something like information disclosure kind of thing, kind of impact, low impacts or information disclosure, and one more possible attacks or SSRF attacks, and the impact is medium level, depend upon the situation. Like if at all, if the attacker is able to grab the cloud credential, then it can go to high and critical, and highly likelihood. Or one more is prompt injection, impact is high, and command injection, and the impact is critical. Same way, rate limit bypass, it will be very, very, very low impact. Session hijacking, if it is a web based thing, and path travel, it's a high. Database breach, the chances are very less, because uh, you know it is not a, I mean, like many of the industries know, it is not a good practice to directly give access to DB. So it's a very rare chance that someone has directly given access to the DB uh, via MCP, right? And very, very, very low likelihood UI redress, that's very, very less. Cache poisoning, very, 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 very less. DNS rebinding is something that can be done on the browser level, which we see already on the MCP inspector that happened, and supply chain attack that can also possibly can happen, right? So real world scenarios which we're gonna discuss on the next section in depth. Something can be on a helpful assistant where customer service with access to database and email tools, where attacker gonna ask like, hey, I forgot my password, can you help me? So AI will help you to reset the password. Now imagine in this scenario, AI doesn't have a capability to validate whether you are actually the owner of that email. Boom, you can modify anyone's password, and you can take over the account directly, right? So similarly, we have some of the very good interesting topics on the real world scenarios which we can look into the next sections. We already discussed this, how the data flow happens from user input to, it will go to LLM, and LLM to MCP client, and MCP client to MCP server, then MCP server hit to database or API. So IH critical point is from here to here, possible prompt injection point, and another one is on the database, and when you give back the response, filtering out the sensitive information. And some of the best practices that one should be aware about: ensure you map all the trust boundaries between AI, MCP, and external systems, and score them based on the your infrastructure, how it can directly reach. Apply stride on each component and build your attack trees based on the entry points. Create a risk matrix based on how how your application is deployed, and the serving capability, like tools capability, and ensure you document every flow and every transformation, and develop the threat scenarios based on the tools. Consider the AI as a both victim and the attacker, because it's going to act as a victim when you have developed the prompts and the prompts and the sampling capabilities on your server, and account for emergent behaviors from the AI interpretation, review the third party MCP servers as a supply chain attack. That's a well thing, like you should be considered in a very important way. And while doing that, consider to have this particular tool as an handy, so that it can help you to harden your MCP server in a best way possible, right? So these are some of the best practices that one can keep in a mind while they're performing the secure design review for a MCP. All right. See you guys in the next section, where we're gonna discuss about some of the real world scenarios.